UFOs on radar. This presentation is aimed at groups and individuals with an interest in the practical analysis of recorded air surveillance radar data, and assumes some familiarity with the concept of primary radar. What are the benefits to UAP research? 1. Situational awareness of the airspace in the vicinity of a UAP event. Most aircraft are required to carry a transponder, a device that transmits an identity code and altitude. 2. The likely detection of unidentified objects and other persistent phenomena, potentially corroborating witness testimony. 3. Multiple radars acting as multiple independent witnesses. When more than one radar detects the same unknown track, the possibility of such tracks being the result of anomalous propagation are reduced to virtually zero. The domestic U.S. radar network. In November 1947, Secretary of Defense James Forrestal announces the intention to create a plan for a nationwide radar network. In 1952, MIT begins work to computerize the network, calling it SAGE, the Semi-Automatic Ground Environment. Today the JSS, Joint Surveillance System, is comprised of over 100 long-range radars shared by the FAA and U.S. military. FOIA requests. Digitized radar data are generally kept for at least 30 days for the purpose of air accident investigation. However, none of this would be of much use to an amateur researcher without access to the data. Fortunately, U.S. Freedom of Information legislation grants U.S. citizens such access. This includes data from the overlapping long-range radars and numerous short-range radars, the latter located in the vicinity of major airports. Making a FOIA request. As this is meant to be a practical presentation, we shall begin with the simple process of making a FOIA request. 1. The FAA website contains a FOIA page, with 3 geographically separate service regions. When submitting a FOIA request, it is necessary to select the correct service region. 2. This presentation assumes that the listener is familiar with latitudes and longitudes, a common frame of reference used for locating points on a globe. Specifying the latitude and longitude, instead of naming an area, reduces the risk of error. From the known locations of the JSS radars, we expect any location specified within the U.S. to fall under radar coverage. 3. Specifying the start and end time. Radar data is indexed using GMT, Greenwich Mean Time, also known as Zulu, and UTC. Specifying the start and end time in GMT also reduces the chance of error made by the FAA when responding to your request. The longer the duration you request, the greater the volume of data, but it is preferable to obtain hours, rather than minutes of data. While this increases the amount of work required to plot the information, automation can prove a highly efficient solution to this problem. 4. Specifying a format. The simplest format is NTAP, or NTAP, but this format is the most heavily filtered and doesn't contain information relating to the identity of the originating radars. An alternative option is to ask for CDR, continuous data recording, a format that usually comes as a report called an editor listing. This listing contains various sections, but we are only interested in target reports. While this format contains the most accurate data, and a code relating to each radar, we need to know the location of each radar, in order to be able to convert individual bearings and ranges to latitudes and longitudes. For short-range radars, We also need the magnetic declination to convert from magnetic north to true north. The third option is a format called stars. This is a compromise between NTAP and CDR. It isn't as accurate as CDR, but each return has already been converted to a latitude and longitude, and the data contains a 3-letter code identifying each radar. Note, there are other formats available that are not covered in this presentation. Extraction and conversion. As mentioned above, whatever format you receive, there will be additional work involved in order to display the results. Of the few researchers currently involved in radar data analysis, most prefer to use a spreadsheet. However, there are free programs and applications available that can produce good results relatively quickly. Radar Plot is a freeware program written in BBC Basic for Windows. This program requires a file of a specific format to provide input data. These input files can be generated by using freeware utilities specifically designed to extract and convert data from NTAP, CDR, and STARS files. Put simply, Step 1 involves extraction and conversion of relevant information, and Step 2 involves plotting or animating the results. Radar Plot is a development of an original program called SV2008, designed to explore the 4 hours of data from the January 2008 Stephenville incident. If you wish to see a demonstration of radar data animation, then contact the author at freeman69@gmx.com. The author can provide a zipped file containing the Stephenville data, the complete Windows Radar Plot program, and a detailed user guide. The author can also provide the free conversion utilities designed to extract and convert common FAA data files. The only cost to the user is the FOIA fee charged by the FAA when requesting new data. These programs will remain free to use by anyone. Interpretation of radar data. Radar files contain 2 types of information. 1. Transponder returns. These are packets of information sent in response to a signal from a secondary ground radar. Secondary radars are most often co-located with primary radar dishes. As mentioned earlier, transponder information includes an identifying code and the altitude of the aircraft. 2. Uncorrelated primary returns. Modern radar systems are quite sophisticated. When a primary radar detects an object, the system attempts to match this return with the data from a transponder signal. The residue consists of uncorrelated primary returns, returns that cannot be associated with a known aircraft. If we are to find evidence of UAP, it will be within the uncorrelated primary return dataset. Recognized challenges. At the start of this presentation, I mentioned the likelihood of obtaining returns from unidentified objects and other persistent phenomena. This was no idle boast. UAP are common to radar and are often called radar angels. The study of common radar angels led to the development of weather radar. However, there are degrees of rarity within the radar angel subset, and they also present a persistent background noise. In other words, there exists a degree of uncertainty as to whether any individual return relates to a specific object or phenomena. The more returns recorded within a specific area, the greater the confidence one can have that a real phenomena is being detected at the location identified. In this respect, there is a statistical element to the process of analysis. It should be remembered that the best results will always come from a strong correlation between visual observation and radar detection. Finally, while radar data is available, by law, in the US, we mustn't forget the rest of the world. Radar formats vary, but the information contained within remains virtually the same. There are definite indications that, if available, radar data from around the world can be studied by any amateur investigator. Thank you for listening.